Hi, Assalamualaikum. My name is Nurusna. I'm gonna present about the definition of declarative living and text gardening. Declarative living is the act of encoding the statements in form that machine can process. Its aspects of the pattern embrace the concept of metadata. Additionally, we often see declarative living at work in any system in which the user can make a public statement either explicitly or unintentionally leave an audit trail of his action. While text gardening is the action of connecting user to a document, image, and audio to help better organize and share interests using tagging. Its aspects embrace inference, a component of artificial intelligence. It is the act of harvesting the declarations to learn about the user's collective state. This pattern is grounded in the collaborative tagging pattern. And finally, a person blogging that she's currently in London would be an example of declarative living and would enable text gardening. The person might also use Google Maps to pinpoint her location or even broadcast her exact current geographical coordinates using Twitter.
Derived requirement of declarative living and text gardening patterns. To facilitate this pattern, you need a mechanism that lets user to make a conscious declaration and optionally associate those declarations with resources. The interface within this pattern must have high usability and be very intuitive and should facilitate data entry in the user's natural language. The Blogger and Twitter interface, which allow users to enter declaration in plain text, are good example. When implementing the pattern, starting as simple as possible with the declaration aspect is preferable. The tag gardening aspect can be built in later phases against either a centralized aggregation of declaration or a decentralized yet index collection. Specific to tag gardening itself, in its initial phases, it should be considered how to divide and aggregate the data to and from multiple computers. Good performance is not an optional because performance is an important feature. Generalized solution. Any successful declaration living service must be extremely easy to use and provide value to the end user autonomously. Otherwise, it will not be adopted. The user generally prefer to avoid spending their time writing the content or relating their terms to nodes in a formal ontology. Even if some did this, the chance of this work being consistently performed are very minimal. Most of new users seem to prefer to get the statement online quickly and tag their resources in their own way. Audio Scrobbler is a tool that stores certain amount of data about music. As an example, Last.fm is a social media platform that connects music fans. They were acquiring Audio Scrobbler, a plugin that listens to a user music player and uploads a log file of their choice. As a result, rather than having a user to sit there and enter a bunch of information about their music, Audio Scrobbler runs in the background and does it for them, providing a continuous stream of musical breadcrumbs. The ability to add all text is not a skill requirement, nor a web skill requirement. Static structure. There is two static structure view in this pattern. First is declarative living pattern view, in which a user or actor interacts with resources and makes assertion about it. People express themselves and aspect of how they interpret their existence through this declaration. This is akin to the collaborative tagging pattern in and of itself. However, it is limited to situations in which a human actor is participating and making the pronouncement, whereas the collaborative tagging pattern is not. A second static view of this pattern corresponds to the aspect of tag gardening. This is where declaration may be subsequently harvested and or aggregated. Note that a human, a machine, or any form of actor can be tagged as a gardening actor. Declaration, once abstract, can be rendered in a variety of ways as previously mentioned.
For the implementation of declarative living and tag gardening, metadata tagging is implemented. Metadata tagging is the process of creating a term that describes a keyword or phrase and assigning those tags to the digital assets in a publication or document. Next is it helps represent yourself with tag clouds or word clouds. Like your opinion on a topic or the terms you use. Basically, the more frequent you use the word, more likely it will represent yourself on those webs. Hierarchies arise in taxonomies according to labels. They provoke distinctions from labels and statements. Next is low complexity and intuitive to use implementation. Next is the specializations of declarative living and tag gardening is music tagging, basically music recommendations that you see. They use tag gardening. Book tagging, recommendations based on reviews you read. The reviews of the books that user has read. Next is URL tagging, search, example, Google web page rank, photo tagging, RFID mashups, and location-based declarations. Other web 2.0 applications that use the patterns are blogs. A blog role is an example of declarative living because the entries on a blog role are text. Next is Twitter. This is a famous example. This web use tag gardening for the topics and trends which are generated from users' preferences and declaration in their hashtags and tweets. It allows people to follow specific subjects of their interest, allowing them to see more content on these subjects on their timeline. Other applications such as Facebook, Flickr, and Napster. Next is the consequences of these patterns. If a simple labeling scheme is used, this pattern can scale easily and be attractive to new users. Next is when labels make their user experience better, users are motivated to generate community, and this community generates attention to potential new users. With new users, web application increase their possibility to generate income. Thank you.
Hi, I am Karunisha Vidwa Mazmin. I am going to be introducing Semantic Web. Semantic Web is widely known as Web 3.0. It evolves from Web 1.0 to Web 2.0 to Web 3.0. It is an extension of the World Wide Web through standards set by the World Wide Web Consortium W3C. It is also a proposed development of the World Wide Web in which data in web pages is structured and tagged in such a way that it can be read directly by computers.
There are a few uses of semantic web, but here are the three main uses of semantic web, which is they assemble data from many authoritative sources in one place, they standardize data collections for improved access and collaboration, and they also allow computers to understand the meaning of data, enabling humans to work more efficiently. Linked open data is connected to semantic web. It makes semantic web possible. Linked open data is a structured data modeled as a graph and published in a way that allows interlinking across servers. It both allows people and machine to access data across servers and interpret semantics more easily. It also makes semantic web transcend from a space comprising of linked documents to a space comprising of linked information, which means it improves from a space of linked documents to a space of linked information. Thank you.
Assalamualaikum. My name is Muhammad Zakir bin Adam, and I'm going to continue where my friend had left off, which is the four rules of linked data formalized by Tim Berners-Lee. Okay, the first rule of linked data is it use URIs. So URIs is Uniform Resource Identifier, which is a unique sequence of characters that identifies a logical or physical resource used by web technologies. This can make each name is unique. So that's why the first rule is it use URIs as name for things. Okay, next rules is we have HTTP URIs, which stands for Hypertext Transfer Protocol URIs. So it use HTTP URIs so that people can look up those names. So these HTTP URIs can produce a link that can link us to a website. Next, we have RDF and SparkQL. So RDF is Resource Description Framework, and SparkQL is a standard for is a RDF query language and a language for semantic query language for database. So this RDF is usually a standard for describing web resource and data interchange, and then SparkQL is just the query language for RDF. And then for the third rules, it's used because when someone looks up a URI, it can provide useful information using the standards. And lastly, the last rules is it's use links. So these links include links to other URIs so that they can discover more things. So for examples for link data is like this image. So let's say that we are searching for Edgar Allan Poe, and then we can found that he is a author of the Raven, and then we can see the link which states for the published date. And then while we are searching for the Edgar Allan Poe, there was also an information about his born on date. And then the other the other example is, let's say that we are searching for a cat. So for a cat is a pet, and then while if we press the pet, and then there's will also have a dog, and then this dog also have a tail, and then this tail it links to a cat since both of them has a tail. And then while we are in the tail category of searching, we found fish, and then this fish connects us to water. So it can link us to a lot of other things through this semantic data. Okay, next, we have semantic metadata. So semantic metadata is tagging existing web. So semantic metadata amounts to semantic tags that are added to regular web page. So for example, homepage of the Bulgarian Institute for Oceanography can be semantically annotated with reference to several appropriate concepts and entities. This will make it easier to find web pages based on semantic criteria. It resolves any potential ambiguity and ensure that when we search for Paris, which is the capital of France, we will not get pages about Paris Hilton. So for conclusion about semantic web, so semantic web is a web of connection between different forms of data that allow a machine to do something it wasn't able to do directly. Semantic web concepts were rapidly adopted in data and information management. Multiple organizations use linked data as a mechanism to publish master data internally. Semantic web standards are widely used in the development of knowledge graph in different domains. So some example that's used semantic web is government, which like legislation.government.uk, and for media, BBC was the pioneer, and then the science, both Elsevier and Springer Nature use GraphDB, and lastly the financial services and many more uses semantic web. So that's all from us. Thank you.